Today we're unpacking a wild solar breakthrough, black metal Stegs, tiny generators that turn heat into electricity. Just jumped 15 times in efficiency. Let's talk about what it is, why it matters, and how you'll soon see it, and where founders can build real products around it. Let's talk about it. What is this, John?
Yeah, so this is cool. And 15 times is huge because, as we know, solar power is not that efficient, right? So researchers at University of Rochester made a solar device that generates 15 times more electricity than previous versions using what they call quote unquote black metal technology. And this isn't your typical solar panel. So let's get into the nitty gritty. So the core innovation lies in them using a femtosecond laser pulse, which is ultra short laser bursts lasting just 1/4 of a second to transform ordinary tungsten into a highly selective solar absorber. So the researchers tested different metals. They tested nickel, they tested copper, aluminum, and tungsten with varying laser parameters to optimize the performance. So the optimized tungsten selective solar absorber, or W-SSA, that exhibited good solar spectrum and weighted an absorption of 0.9, which, I looked this up, it's about 3 times higher than a bare kind of ceramic absorber. And it also maintained an infrared emissivity nearly as low as untreated tungsten. So why this matters. So this could power sensors, wearable electronics, remote devices that need reliable, maintenance-free energy. Unlike solar panels, STEGs can work with any heat source and don't have any moving parts, which makes them perfect for harsh environments. This is cool. I like their approach here. So what are your thoughts on this, Craig? Do you think this is the next step in solar energy?
Yeah, I really like this. I mean, I don't know yet whether this will be the next step in solar energy, but it's definitely an addition. These solar thermoelectric generators, the Stegs or the STEGs, they use laser treated black metal to absorb sunlight as heat, so they won't be nearly as reflective as some of the stuff they use now, which is interesting. And like we've got a breakdown on torontostarts.com, check it out. But there's the hot side enhancement, there's the heat trapping mechanism, and then there's the cold side optimization where it's laser etched aluminum heat sinks featuring nanostructures that double as cooling performance. So that these enhance service improvement and radiation because it's the difference in the heat that this stuff measures, right?
Yeah.
Any time we can boost our solar efficiency, I'm on board because we don't quite have the efficiency that's working as well as we want. Let's just face it. And we need better solar and wind technology if we really want more large scale adoption. Because residential solar panels achieve roughly 20% sunlight to electricity conversion. However, photovoltaic systems use only certain light wavelengths and waste significant thermal energy.
Yeah.
So using the photovoltaic and the new Steg 15 times more efficient, but combining them, you're going to get even better.
Yeah, and there have been in the last year, there have been some solar technology advances like the perovskite tandem cell records, the commercial panel efficiency, and the flexible and transparent solar. So there are other ways, but those haven't really achieved the efficiency that they have with the STEGs. So, but the cool thing about this is the team's approach that they're doing kind of addresses key commercialization changes or challenges by using single-step laser processing instead of a complex multi-layer deposition technique. So the technology itself could be used to power wireless sensors like we talked about for the IoT, fuel wearable devices, and service off-grid renewable energy systems in rural areas, which is interesting. So based on what I've read and based on what I researched, this has commercial viability relatively soon. Is that what you took out of this?
Yeah, I had this And let me look at how much you learn, main concerns. It's lab stage now with promising, expecting near-term pilot IoT wearables and broader products typically within a couple of years.
Yeah. Yeah.
Once their ability and manufacturing scale are proven, we should see them.
Yeah. And just some numbers that just to kind of reiterate the numbers, 80% solar absorption efficiency with the black metal technology, 40% reduction in convective heat loss with the greenhouse chamber, and 180% increase in cooling surface area with the microstructured aluminum, and also 25% weight increase for the complete system. So that's not the best, but as far as the other increases that you're getting, I think that's a good trade-off.
Now, did you read anything about hot or cold climates for this?
I did. I didn't find anything on specific hot and cold climates.
No, I was just kind of going through to see, because of the way it does it, I wonder, would get as much electricity in, say, Canada in the winter on a bright sunny day versus, say, somewhere else?
Because it uses heat differential, right?
Yes.
Yeah. So, yeah, that's a good question. The cool thing about this is that it's maintenance free. So being up in like the north is probably good for it. But as far as the technology itself and how well it would work in extreme environments, I don't know. I like it. Like that's a great question to ask. That's a great problem that they might run into that they'll have to solve.
Yeah, and durability is one of the things that's on the list to solve. So we'll have to wait and see, but I'm really interested in where this is going. Anytime they can improve solar panel, I'm in. Anytime we can get better technology around this stuff, like I'm not there yet, but we're getting there. Like, you know what I mean when we're talking about renewables, 20% plus this, plus that. Once we're getting to 40, 50%, now you're starting to talk about a real solution that can convert energy. We still got to update our grids and update our policies around what we do with the energy coming from homes, because at first you were able to tap into the grid and feed back any extra electricity, etc., and get credit for that. Now most places don't allow you to do that anymore.
Yeah.
So hopefully they get kind of that sorted, because with your peaks and valleys, otherwise you got to have big battery storage for a lot of stuff. And so anyway, this is great technology. I love where this is going. Any last words on this, John?
No, we'll have to cover this to see when it gets commercialized.
So photovoltaics turn sunlight into Internet of Energy. Black metal Stegs could be its edge servers. Quiet, tiny, everywhere. Keep your eye on the hybrid PV plus Steg devices in real world devices soon. What do you got going on, John?
Oh, just working away, helping companies secure government funding. I'm maybe heading to a couple events. Not sure what's coming up. So this will probably come out after Elevate.
Yeah.
So Elevate probably would have been a great time. But yeah, how about you, Craig? What do you have?
So assuming this is in November, we got a Flowgrammer event and a Toronto Startup Investor Drinks. If you're in the GTA area and want to learn or be part of a Flowgrammer, N8N, or Vibe Coding meetup group, join us. Go to flowgrammer.ca and check out the upcoming events and join us. If you want to find out more about how to take your startup to the next level, head over to torontostartups.com. Our events there, Startup Investor Drinks. So we do monthly. It's open bar, open pitch. It's an intimate event, and the conversations are next level. So check all that out there, and we'll see you in the future. Anything else, John?
No, that's it.
So thanks, everyone, for listening. Don't forget to like and subscribe and leave a comment. We really appreciate it. Have a great one.